Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on ring theory, lecture number 16, in which I will prove some theorems on field. Now we prove a theorem. Theorem is a field is an integral domain. Proof. Let F with binary composition, addition and multiplication is a field. Therefore, F with binary composition, addition and multiplication is a ring. Number 2, having unity element. Number 3, commutative with respect to multiplication. Number 4, each non-zero element is a unit. Let small a belongs to F such that a not equal to 0. Therefore, each non-zero element is a unit, implies that A is a unit, implies that A inverse exists. Let B belongs to F such that A multiply B equal to 0, implies that A inverse multiply A multiply B equal to A inverse multiply 0, implies that A inverse multiply A multiply B equal to 0, associative, and right side is 0 only for multiplication of an element with 0 is 0, implies that this is unity element, multiply B equal to 0, implies that B equal to 0, implies that A is not a left divisor of 0. Since F is commutative, therefore A is not a right divisor of 0. Therefore, each non-zero element of F is not a divisor of 0. This is number 1. Therefore, F with binary composition, addition and multiplication is a commutative ring with unity and containing no divisor of 0, implies that F with binary composition, addition and multiplication is an integral domain. That is, a field is an integral domain. Proved. Now we prove the next theorem. Theorem is, let F be a field, then non-zero elements of F form a commutative group with respect to multiplication. Now we prove this. Given that F with binary composition, addition and multiplication is a field, Therefore, number 1, F with binary composition, addition and multiplication is a ring. Number 2, having unity element. Number 3, commutative with respect to multiplication. Number 4, each non-zero element is a unit. Let F star equal to F minus a set containing only zero element. That means F star contains all non-zero elements of field F. Let number 1, A, B belong to F star. Since F star is subset of F, therefore A, B belong to F and A not equal to 0, B not equal to 0. A, B belong to F implies that A multiply B belong to F, because F is closed under multiplication. And A not equal to 0, B not equal to 0, that means A multiply B not equal to 0. Since it is a field, so this field is integral domain. So it contains no divisor of 0. Here A multiply B belongs to F and AB not equal to 0, that means A multiply B belongs to F star. Therefore, F star with binary composition multiplication holds the closure property. Number 2, let A, B, C belong to F star. That means A, B, C belong to F and A, B, C are non-zero elements of F. Since F is associative, therefore A multiply under bracket B multiply C equal to under bracket A multiply B multiply C. Therefore, associative property holds in F star with binary composition multiplication. Number 3, since F is a field, therefore F contains unity element. Let I be the unity element of F, therefore I not equal to 0 element. If I not equal to 0 element, then I belongs to F star, non-zero element of field F. Therefore, I will be the unity element of F star. Number 4, let A belongs to F star and F star is subset of F, therefore A belongs to F and A not equal to 0, means non-zero element of F. Since each non-zero element of field F is a unit, therefore A is a unit, implies that A inverse belongs to F. Since A not equal to 0, implies that A inverse not equal to 0. Therefore, A inverse is a non-zero element of field F. Therefore, A inverse belongs to F star. Therefore, each element A belongs to F star has multiplicative inverse. Number 5, let A, B belong to F star, means A, B are non-zero elements of F and F is commutative with respect to multiplication. Therefore, A multiply B equal to B multiply A. Therefore, F star with binary composition multiplication is commutative. Hence, F star with binary composition multiplication is a commutative group. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.